Hey there, Chem Squad. In today's lesson, we're going to look over reaction mechanisms. So just to review a little bit, in past lessons, we've talked about catalysts and intermediate molecules. So a catalyst is any type of substance that you add into the reaction. So it's typically some kind of reactant. Now, this particular reactant basically increases the speed of the reaction, but more importantly, the catalyst is reformed at the end of the reaction. So it's not used up or consumed. Okay, it's basically added in. So what you put in, you get out at the end. Now, as for the intermediate molecules are basically in between molecules, kind of like a transition molecules. So they're not really reactants, but they're not fully formed products yet either. There's something in between. Now, these guys are created during the reaction, and they will be used up in a later stage of the actual reaction itself. So to give you an analogy of an intermediate molecule, think about using Legos. Okay, so for example, I have a whole bunch of Lego pieces here. Let's call them the reactants. And typically in a chemical reaction, we see the reactants, we see the arrow, and then we get the final products. But in actual fact, in an actual reaction mechanism, we actually show that there are intermediate molecules, okay, that also exist. So these are your in-between steps. So your reactants or your Lego pieces, the intermediate molecules, there could be more than one of them, are all the little in-between steps that basically help to form your finished version, the final product. In this case, it's a nice, pretty cool looking race car. So when we look at a reaction mechanism, okay, now a reaction mechanism is basically, oops, let's get my pen started. Okay, so a reaction mechanism shows all of the smaller steps of a reaction. Okay, the things that we normally don't see in a regular chemical reaction, right? We just see the reactants and the products, but here you see all the smaller steps that the reaction has to go through in order to form the final product, okay, of your overall reaction. So at this point here, if I was organized, okay, I might not be, but hopefully I am, you should have a reaction mechanism handout. So if you don't, I likely have a PDF that you can download from Google Classroom, or you can pick one up the next time I see you in class. So on this handout, I have a whole bunch of examples of different kinds of reaction mechanisms. So I'll take two of these examples and I'll go through them with you here. So the first example. The first example is to find the overall or net reaction for the reaction mechanism below. So this is what I mean by a reaction mechanism. This is a two-step mechanism. So we have two smaller steps that make up the final reaction, which is called the net. So it's very similar to math, where you're combining equations into one equation. So each step is its own chemical equation. Now, how we go about this is we have to look at where the arrows are. Okay, the arrows separate your reactants from the products. Okay, so reactant side, product side. Now, if you look at the reaction carefully, okay, between step 1 and step 2, we have chemicals that are identical to each other. Okay, but they might appear on different sides of the reaction. So for example, I have Cl on the reactant side, and here I have Cl on the product side. When you see two identical substances, okay, that are on opposing sides of each other, okay, we can cancel them out. So the chlorine on the reactant side can be canceled with the chlorine on the product side. They're not included in our net reaction. Now, Similarly, here you have ClO. It's on the product side. You have ClO on the reactant side. These two can be cancelled out because they're on opposite sides. Now, if you look carefully, there's an O2 here and an O2 over here. However, they're both on the same side. So because they're both on the product side, we cannot cancel them out. Okay, so once we have canceled everything else out, okay, whatever is left over, we collect at the bottom. So from step 1, we have O3. From step 2, we have oxygen. So O3 plus O yields 2 molecules of O2. So this is our net reaction. So the net reaction is the overall reaction. Okay, so normally when you look at an overall reaction, it should be balanced already. Okay, so we have 3 oxygens plus 1 oxygen, that's 4 oxygens on the reactant side. We have 2 times 2, which is 4 oxygens on the product side. So in our final reaction, we can see that it only deals with oxygen. We don't even notice that there are chlorines present. Okay, but chlorine is present in the reaction mechanism because they were a part of step 1 and step 2. So this one here is correct and done. There is a reason why we see those chlorines and chlorine oxides. Okay, we'll get to the reason in our second example. So this first example, I just want you to be able to figure out the overall or net reactions by canceling out substances that appear on opposite sides of each other. When we look at the second example, we'll go into more of a detailed explanation in terms of what those substances are that we're canceling. So for this example 2, okay, the ultimate goal is to find the net or overall reaction again, just like in example 1, but this time we also want to identify which of these molecules are intermediates and which ones are catalysts. Okay, so let's look at this example together. Now, again, we will identify the reactions, the substances that are identical but are on opposite sides of the reactions. So for example, I find that there are 2 C's, okay? One's on the product side, one's on the reactant side. There are 2 E's, again, one on the product side, one on the reactant side, okay? There's 2 F's, but they're both on the product side. There's 2 B's, but they're both on the reactant side. There's only one of A, okay? The only one that appears on 2 different sides are basically D, okay? We find D on the reactant side, and we find D on the product side. So figuring out the net reaction is the easiest one to do. So we draw a little line, okay? We're going to add basically all of these steps together. We're going to combine them together, okay? But again, excuse me, anything that I've circled or squared, those are the ones that are going to get canceled out, okay? Now, before I cancel them out, actually, I won't cancel them out right now. I'll just collect the items that are remaining, okay? So on the reactant side, I have an A. On the product side, I have 2 B's, okay? Sorry. On the reactant side, I have an A. On the reactant side, I also have 2 B's, okay? Sorry about that. On the product side, I have 2 F's. Okay. All the other ones would have been canceled out. Okay. Now, before I cancel them out, we kind of need to figure out which ones are intermediates and which ones are catalysts. Okay. So the easier one to look at first is actually the catalysts. the catalyst should appear on the reactant side first, okay? Because it is a reactant that you add into a reaction, and then they get reformed later on as a product, okay? So this one gets added in as a reactant, and then it gets reformed as a product. So D is a catalyst, okay? And catalysts are not included in our net, so we can cancel them out. So that means C and E, okay? Both C and E are what we call intermediates. Okay. The intermediates are your in-between molecules. They are formed during the reaction. So for example, C here is formed during reaction 1, step 1. They're formed as a result of A and B combining together. Now, this intermediate gets used up in a later step. So that's why we see C again, but this time on the reactant side. So it first appears on the product side, then it appears on the reactant side. If that happens, it's called an intermediate. E appears on the product side because it's formed during the reaction, and then it's used up in a later step as a reactant. Okay, so we can cancel them out. So once all the catalysts and intermediates have been canceled out, we basically have A plus 2 B's to give you 2 F's. Okay, so we never include our catalysts and intermediates in the net reaction. Okay, the net reaction just involves the reactants that turn into products. So if we actually went back up to example 1 again and applied what we know now, okay, we can find that there is a catalyst here. Okay, the catalyst is Cl. It first appears on the reactant side, and then it appears again, being reformed as a product. For the other cancel out item, ClO, ClO first appears as a product, and then it gets used up as a reactant in a later step. So that makes it an intermediate. Okay. Now, there's no rule that suggests that there always has to be a catalyst. Okay. A catalyst can be put into a reaction, but a catalyst is always something that's optional too. So if you do a reaction mechanism and you don't find a catalyst, that's okay, because there might not be one. However, there are always intermediates. Intermediates are what connects the different steps together, okay, to make up your final products. So intermediates must always be present in the reaction mechanism. So let's just summarize everything again. Remember, catalysts appear on the reactant side first, then again on the product side in a later step. Intermediates appear on the product side first, then again on the reactant side in a later step. So the main thing is catalysts are first seen as reactants, intermediates are first seen as products. Okay? Now remember, we must always have intermediates. The presence of a catalyst is not always necessary. So like I said, if you do have the handout, okay, with you, give the rest of those questions a try. Okay, they're very similar to the 2 examples that I showed you for this particular lesson. And eventually I will most likely post a answer key for this either in class or on Google Classroom. That's all the time I have for today. See you guys soon.